Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. None greater than the Sahara Desert, the hottest place on the planet, a deadly wasteland that time forgot. Or so scientists believed, till they unearthed a series of startling clues. The fossils of sea creatures, freshwater shells buried in sand, ancient settlements with human remains. Clear evidence that this stark landscape hides a turbulent past. One that would alter the course of human history and provide a dramatic new chapter in the story of how the Earth was made. Africa's vast Sahara Desert is as big as the United States. The sand alone from this giant expanse could bury the entire world 8 inches deep. It's the largest desert and the hottest place on Earth.
When I first arrived in the Sahara, I was just struck by how utterly barren it was. It's like the color green was removed from the palette when they made this place. Just nothing, grays and browns, and not a scrap of life.
Smith's mission is to unearth evidence of what made the Sahara into the wasteland it is today. Her investigation begins on the desert's far eastern edge, in Egypt. Not in the sands of the Sahara, but in one of the most epic structures ever built by man, the Great Pyramids. The building blocks of this ancient wonder house a remarkable clue to the history of this land, from a time long before the pharaohs even existed.
So, taking a closer look at these blocks making up the pyramids, there's actually these gorgeous marine fossils in here. Most obvious are these flat discs up to about 1 inch wide. They're called nummulites, and they're actually single-celled organisms.
The name nummulites means little coins in Latin. They are some of the largest single-celled creatures to have ever existed. In ancient times, these blocks were cut from quarries across the country and dragged to the pyramid site. Each block weighed 2.5 tons, and it took 2 million of them and over 20 years to build the Great Pyramid. And incredibly, up to 40% of each building block is made up of the bodies of ancient sea creatures like these. What's even more important about the marine nummulites is that they date back 40 million years, and they only lived in water.
It's a piece of evidence that this area, now desert, was once underneath the ocean. You think about the construction of the pyramid, but not necessarily about what it's made of in these gorgeous fossils.
The Sahara now is the world's biggest dust bowl. But the tiny nummulites fossils suggest that it was once very different, that perhaps there could have been water in this barren wilderness. Smith heads further inland to investigate this extraordinary idea. She travels to a remote desert valley near where the pyramid stones were quarried. It's called Wadi al-Hitan. Spread out in the sand lie hundreds of fossils, first excavated in 1983. But these are nothing like the tiny nummulites.
That's a whale. So here's the backbone, the vertebrae. Here's some ribs, shoulder, part of the front fin, and there are the jaws. This guy definitely did not live in a desert.
This incredible fossil is a Dorodon, an ancestor of modern whales, one that died out 36 million years ago.
So based on the size of these vertebrae and how much of the animal was here, it was probably about 21 feet long. This guy tells us that we were underwater. We were in the middle of an ocean.
Wadi al-Hitan is Arabic for Valley of the Whales. This 12-mile dip in the landscape has the highest concentration of fossils in the world. Some were found in the desert floor, others in the cliff walls. The count so far is 400. Almost all are marine animals. Further evidence that the Sahara was once covered by sea.
So here we've got the fossil of a baby whale. You can see the lower jaw down here with some teeth, and the shoulder, the backbone, some ribs, and all curled around. Actually, the tail comes right back to near the head.
As if finding whales in the desert wasn't intriguing enough, there's yet another mystery to be solved. A lot of the fossils are of very young Dorodons, like this one. A delicate mesh of stone helps explain why so many baby whales died in this place.
Wow, so finding that whale fossil told us we were in the ocean. These rocks actually tell us a lot more about what type of ocean we were dealing with. These are all fossilized mangrove roots.
These roots would have been below water. The mangrove trees would have risen above it.
Since trees don't grow out of the deep ocean, we know that this area was actually under shallow ocean at the time these rocks were deposited. Something probably that looked like the Florida Everglades, where there are mangroves growing now.
Smith has discovered the shoreline of the ancient sea. The shallowness of the water could explain why there were so many young animals here.
So one idea, there's a bunch of these baby whale fossils found in this area, and this would have been a shallow protected bay that maybe the whales came just to birth their young. It is absolutely incredible to see a fossilized whale in a place that right now gets less than 1 millimeter of rainfall a year. It's as much convincing evidence for geologic change as I can imagine.
The pieces of the puzzle are coming together to reveal the Sahara's watery past.
So 40 million years ago, this desert would have been covered in the middle of this valley by a shallow bay, probably a brilliant tropical blue-green color. The shoreline would have been off along the horizon, some mangrove trees in the shallowest parts of it.
Inland would have been a vibrant combination of rainforest and swampland. The whales would have been drawn to this ancient shore because of the plentiful supply of food. But their ocean is about to vanish. Marine fossils found in Europe and Africa are evidence that this ocean stretched almost halfway around the world and connected Asia to the Atlantic. It's called the Tethys Sea, and much of the Sahara was submerged under it. The mystery is how and when this lush water world turned into the barren wasteland we see today. The answer lies not in climate patterns, but in geology. The entire African continent is underpinned by a giant piece of the Earth's crust. It's called a tectonic plate, and 40 million years ago, in what is known as the Eocene Age, it was on the move.
So at Wadi al-Hitan, we have whales swimming around in this Eocene Ocean. All the while, the African plate is moving to the north.
Africa collides with Europe, closing the Tethys Sea. But the African plate keeps moving.
So we uplifted the northern part of Africa, and so the Tethys Sea recedes. And we've got this whole area of North Africa now emerged. It's out on land.
The whales of Wadi al-Hitan are cut off and trapped in smaller and smaller pools of water. The deadly Sahara has claimed its first victims. In the quest to discover the history of the vast Sahara Desert, geologists have so far uncovered 2 important clues. Sea fossils in the Great Pyramids of Egypt show these building blocks were once underwater. Whale bones reveal that a sea submerged much of the Sahara 37 million years ago. As the forces of plate tectonics pushed the Sahara out from under the sea, it created a tropical swamp. In order to figure out what made it into the wasteland visible today, scientists have to pinpoint the moment of its birth. But the clues to this mystery turn out to be hidden in the last place anyone expected. 20 million years ago, the Sahara Desert was a lush tropical swamp. Geologists are now piecing together the story of the next 20 million years. Today, the Sahara lies in what is known as the Desert Belt, a region of dry air north of the equator. Here, strong winds clear the sky of clouds and dry out the land below. It stretches through the Gobi Desert in China and across the deserts of the southwestern United States. The Sahara is the largest, and yet geologists know next to nothing about when it was created.
What we have are just these little bits and pieces, these snapshots of what the Sahara was like, because the wind blows away a lot of our record, and what isn't blown away is often covered by sand, so it's kind of hard to find the rocks we need to tell the story we're trying to tell.
One of the few places that shelters a clue to the Sahara's birth is the White Desert. In this hauntingly beautiful site, dramatic shapes have been sculpted out of rock.
Oh, this is great. It's got that mushroom shape.
These structures are called yardangs, and they are a kind of hourglass that could help measure the age of the desert.
This rock is another piece of evidence that this desert was once under the ocean. It's actually a chalk made up of billions of little marine microorganisms. These chalks are actually really easy to erode, so that's one reason things are so beautifully sculpted by the wind.
But the wind is a brutal creator. It picks up sand and hurls it at the yardang.
When wind scours or sandblasts the rocks, this is the characteristic shape that we get, this mushroom shape, narrower in the middle. That's because the wind goes faster as you move up from the ground, so it can erode harder, but it has less sand in it since it picks up the sand from the ground. So where we get the most erosion, where the rock is narrowest, is where we have the best mix of fast wind and the most sand.
40 million years ago, the top of the yardangs formed part of the solid sea floor. But the wind picked up once the Sahara turned to desert, and the process of carving out these shapes began. Figuring out how long that took could help pinpoint the age of the desert.
It's hard to say precisely how long it would take for the wind to carve this all out. Something like this, about 15 feet high, soft rock, you're looking at maybe only tens to a few hundreds of thousands of years. But to carve out the whole Oasis Depression, you've got to need at least 1 million years.
But geologists suspect the Sahara is older than 1 million years. In their search for a more accurate date, they next turn to its most iconic feature: sand dunes. Here in the Sahara, sandstorms kick up that can last for 4 days. The sand is hurled across the terrain. Over hundreds of thousands of years, it accumulates into dunes that can tower 50 stories high. Perhaps these mountains of sand hold the secret of the desert's great age.
As soon as the climate becomes arid, you can start building dunes. And if we want to know how long that took, we can try and date the dunes themselves, but that's really hard.
What's hard is that these dunes are constantly shifting. The wind that builds them also blows them away, moving them an average of 50 feet a year. To get a precise age for the desert, scientists need to follow the sand to the end of its journey.
Coarse sand travels slowly and doesn't go all that far, but the finer particles will actually travel further. And so dust-sized particles actually can get carried out into the Atlantic.
The Sahara is the largest source of dust on the planet. 500 million tons of it ends up in the Atlantic every year. Some of it reaches as far as Florida and creates spectacular red sunsets. But much of it settles on the ocean floor, a treasure trove of information about the Sahara's past.
What's wonderful about working with the ocean sediments is that they capture everything. They're this very faithful recorder of the sediments that are raining down from the surface.
In 1995, Domenical drilled down into the ocean floor through layers of mud dating back millions of years. Each layer of sediment is like a time capsule. Shallow levels show plenty of this dust blown over from the desert. So Domenical extracted deeper core samples from over 1 million years ago. Still, there was desert dust. Finally, he dug down to a layer that was laid down 3 million years ago, and there, the dust finally stopped. It had taken a voyage to the ocean floor to uncover the turning point from humid tropical landscape into searing desert.
That's a pretty amazing change. You don't think of something as large and expansive and fixed as the Saharan desert as being something capable of such profound changes. And yet this is what the geologic record was telling us.
Domenical had finally solved the riddle of the sands. The Sahara has been a desert wasteland for 3 million years. In the search to discover the age of the Sahara, geologists have unearthed 2 startling clues. Yardangs show that wind-blown sand has been blasting across the desert for at least 1 million years. Deep-sea cores give a more exact date. the Sahara first turned from swamp to sand 3 million years ago. From that moment on, the Sahara became the searing wasteland we see today. It seemed that geology alone could explain the creation of the world's largest desert. Then, a new radar fitted to the space shuttle revealed a striking clue that the desert once harbored a slash of green across its burning sands.
Booster ignition and liftoff.
In 1981, the space shuttle made a surprising discovery. Using a new type of radar, NASA took a 30-mile wide scan of the Sahara Desert. The radar pierced the sand to a depth of 16 feet and revealed what looked like a hidden network of ancient waterways crisscrossing the desert. This finding stumped scientists. 3 million years ago, the Sahara turned from rainforest into desert. Now it seemed that it had been home to a lot of water at some point in the following 3 million years. Researchers followed the NASA images north into Tunisia, to the edge of a deep depression in the Sahara, the site of their first clue.
This is what we're looking for. Got some quite intact shells here. This deposit is largely composed of intact shells.
And these are not shells from the ocean.
So here we have half of a Cadastroderma glaucum shell, which is a clear sign of a freshwater lake. This is just one example of what must be millions of shells. We must be somewhere near the shoreline of the lake here.
Further shell deposits revealed that this lake was giant, about the size of West Virginia. But the shells provide even more remarkable evidence: the date when this lake existed. Carbon dating puts them at 90,000 years old and leads to one conclusion.
To have all these shells here, we must have had a lot of rain falling in the vicinity of this lake and a green Sahara.
Scientists fanned out across the Sahara to investigate other satellite images. They searched for any dips in its landscape that looked like they once held a body of fresh water.
So what was really exciting for me about those radar images that were produced by NASA, we can link this to the GPS, and we're finding evidence of lakes throughout the desert. And some of these lakes are massive.
3 different lake locations were confirmed by the presence of freshwater shells. The series of ancient lakes were so large, they've been dubbed mega lakes.
So this is the far shore of the mega lake. And there's just one of many lakes across the green Sahara.
When Drake added up the evidence of all the lake locations, he uncovered an astonishing fact.
Okay, so if this is North Africa here, and this is the edge of the Sahara Desert, so we're here in Tunisia with a mega lake here, and we know there's another mega lake here in southern Libya, an even larger one here in Chad. If they all reached their maximum size, they would have covered 10% of the Sahara.
That would have made them 3 times larger than the Great Lakes. What is now the biggest desert on Earth was once home to some of the planet's largest bodies of fresh water. Sudden changes in climate have been connected to everything from volcanic activity to meteors hitting the Earth. But climate researcher Peter Domenical had a hunch this wasn't the first time it had happened. He turned to his archive of deep ocean cores.
Our approach was to use deep-sea sediments as this continuous tape recorder, if you will, of past climate change in Africa.
By looking at the levels of desert dust in cores dating back hundreds of thousands of years, he discovered the Sahara had changed more than once.
When we first collected these measurements, I really kind of almost fell back in my chair because what we saw was there are many switches like this in the climate system.
To explain these regular dramatic changes, Domenical looked beyond the Sahara to the rotation of the Earth itself. More specifically, small wobbles in the Earth's orbit around the Sun. The theory is that the wobble causes the Earth to tilt slightly. So the monsoons which drench southern Africa today shift up, pouring rain onto the dunes of the Sahara. Crucially, these wobbles occur every 20,000 years.
So there's this perfect one-to-one match between when Africa was wet and the stage of the wobble cycle. And this goes back millions of years.
Each time the rain belt moves up, the landscape is transformed, and the desert turns green.
To me, the single most impressive thing about the Sahara is how small fluctuations in something as simple as a wobble in the Earth's orbit can lead to these really just totally dramatic changes in the climate of a region that's so large.
Scientists now had evidence of how and why the Sahara turned green. They knew that giant lakes covered much of the desert, but they had no proof they were connected. Were these vast, isolated rain pools or part of an interconnected river system, as suggested by NASA's radar images? Nick Drake gets word that in 2009, archaeologists have made an important discovery that supports the river theory. Stone tools found not far from the site of the megalake in Tunisia. The first step is to identify the shoreline of the ancient lake.
Now looks good. So, we've got some freshwater mollusks.
These tiny shells are a good sign of the lake. Now he searches for what may have been drinking the water when the megalake existed.
We have what looks like a part of a jawbone of a small herbivore. You can see 3 teeth running along there. Some sort of gazelle.
So animals must have existed here in the desert when it was green.
Okay, so we've got a stone tool here. It's become blunted, and they've retouched it with a lot of very fine flakes off the edge. The fact we've got stone tools and we've got dead animals suggests hunting. And this was the animal that had been hunted. And then we've got water, so people sitting around a water hole waiting for animals to come to drink and then killing them, eating them, leaving them behind.
It's an important find. A Stone Age tool shows people lived on the shore of this ancient lake. And 90,000 years ago was a turning point, not just in the story of the Sahara, but in the history of humanity itself. We are all descended from one group of people in East Africa, the birthplace of humankind. Sometime between 80 and 120,000 years ago, modern humans started the long journey out of Africa. No one knows for certain what route they took. The prevailing view is that the Sahara was impassable, so humans left East Africa and traveled to the coast, then crossed a land bridge into the Arabian Peninsula. But Drake suspects that if the megalakes were fed by a river system, it would have created a green corridor across the burning sands.
So our ancestors could have followed these river systems, gone round the lakes, follow the next river system, round the next lake, and the next river system and the last lake, and then they've been in North Africa, and it'll be simple for them to just move out. The lake is a good story. The rivers plus the lake is a very concrete story.
To find proof of his theory, Drake heads to one of the few areas in the desert where water still flows, an oasis. He finds a small spring that shelters a valuable clue.
Caught some. Great. Cichlid fish. Nearly all cichlid fish are found south of the Sahara Desert. This particular type of cichlid is the only example north of the Sahara Desert.
This cichlid bears a strong resemblance to its closest relative that lives in Lake Tanganyika. But this lake is almost 3,000 miles away on the other side of the Sahara.
So, the big question is, how did it get here? And the most obvious answer is that it swam across the green Sahara. Modern humans, who could live in lots of different types of environments, would have presumably found it very easy. A darn sight easier than this fish.
These rivers and lakes were not to last. The door slammed shut on the green corridor. But scientists now know that the Earth's wobble makes the Sahara like a pendulum. It goes from wet to dry every 20,000 years, like clockwork. The investigation has now revealed 2 clues to how these wobbles affected the Sahara. Freshwater shells dating back 90,000 years prove the desert was once covered by giant freshwater megalakes. A cichlid fish shows the Sahara was crossed by a river that created a corridor of life across the sands. But scientists still needed concrete information about how rapidly these changes occurred. Then, an Egyptian archaeologist made a stunning discovery in the Libyan desert. An eyewitness account of the Sahara's last switch, the most dramatic climate change of the last 10,000 years. Scientists piecing together the history of the Sahara have uncovered a remarkable story. 40 million years ago, it was covered in ocean. 3 million years ago, the Sahara turned to desert. Since then, it has swung between grassland and wasteland every 20,000 years. Scientists now turn to the more recent geological past, the last 10,000 years, to discover how fast this giant desert can change. Investigators head to a valley deep in the Libyan desert. The first clue to unraveling the mystery is a small circle of stones.
This is essentially the foundation of a hut. It is unimaginable to see an actual house structure right there next to what is now nothing.
Hassan's discovery is striking evidence of human habitation.
The house structure consists of this circular foundation with upright standing blocks which are taken from the local bedrock. It would have made a semi-circular structure with probably skins and branches, and people would have used that as a shelter.
Hassan believes these huts could have housed a small community of around 50 people. Now he needs to know exactly when they lived here.
Ostrich eggshell beads.
These little ostrich egg beads are clearly human handiwork.
They use the eggshells to make ornamental beads cut into a circle so that a string can pass through. So they string these into bracelets or necklaces.
The eggshells the beads were made from are also here and provide the next clue.
The eggshells suggest, of course, that they were ostriches, and that's quite remarkable for this environment to have animals like that.
This was no nomadic tribe, but a settled farming community rearing animals for food. Hassan carbon dated the ostrich eggshell beads. The result? Just 7,000 years ago, the deadliest desert on Earth was home to both human and animal life. It's dramatic evidence of the last burst of green in the desert. A dip in the desert floor provides a clear sign that rain from the monsoon fell here.
What we have here is the evidence of a deep lake with mud deposited.
This mud indicates a body of water that could have supported a settlement of people.
When the lake is deep, as we can see from these layers here, then there would be a lot of vegetation, a lot of animals, and people would have a very good time.
At sites all across the Sahara, scientists have excavated similar evidence of life. The remains of elephants and gazelles, hippos and crocodiles. Remarkable cave paintings even show people swimming. Elsewhere, human bones have been found, carefully buried in what were lakeside graveyards. Analysis of these bones reveals they date from between 10,000 and 6,000 years ago. The question now for scientists was how quickly the Sahara changed from bountiful back to bone dry. Earlier, deep-sea cores had provided evidence of the moment the Sahara first turned to desert 3 million years ago, and of how, since then, a wobble in the Earth's axis has made it swing like a pendulum between desert and grassland. Now, climate researcher Peter Domenical's on the hunt for the Sahara's last switch from green to desert, one that occurred in the last 10,000 years. To a geologist, opening this core is like a portal back in time.
Wow, that's amazing. Much, much redder in the upper part of the core.
Laid down flat, every quarter-inch of sediment in the core represents 200 years. The color difference in the sediment is subtle, but to a practiced eye, it's a big clue.
When we split this core, what is surprising about it is that we see this really impressive color change, and it's It goes from this sort of darker green-brown color in this section of the core, which comes from the clay minerals that make up the deep-sea sediments. This bright red sediment actually comes from the wind-blown dust that's coming off the Saharan desert. As you move along this core, you can see this color maintains itself further up and up in the core. So right now we're about 7,000 or 8,000 years ago. Boom, here is the drying of the Sahara. You can put your finger on it in this core right here at 5,500 years ago.
Crucially, the proximity of these two layers reveals how quickly the switch happened.
The transition from a very well-watered, wet Sahara that was completely vegetated to one that was much, much drier, that climate transition in this core occurred within 1 or 2 centuries.
Scientists knew that the Sahara was an ever-changing environment. Now, for the first time, they had a sense of just how fast it changed. As the Earth wobble shifted the rain belt away, the return to desert was swift and deadly.
These transitions would have happened almost on a generational timescale, that one generation after the next would have realized that where they're living is no longer sustainable.
High above the ruins of the lake settlement, Fakhri Hassan has discovered a cave he believes was important to the Saharan people during this sudden change in climate. Perhaps it holds eyewitness clues to what happened.
When I first came into the cave, the sand was as high as this level, and I had to crawl in because the sand had covered the whole area. Well, this wind-blown sand cannot form when the desert is green.
Buried in the sand was the first clue, some perfectly preserved animal droppings.
So these animal droppings don't only tell us about the climate at the time, but they also are excellent materials for radiocarbon dating, which allow us to date the final event of the drying of Sahara.
These goat droppings, covered in sand, reveal a time when a farming community was overwhelmed by desert. Hidden in the back of the cave is a clue that confirms people sought shelter here.
The cave has a very interesting feature, which is the prints of hands. So this is excellent evidence of the people that lived here.
The next clue suggests that around them, the Sahara was beginning its relentless transformation into desert.
Well, here we see a very interesting drawing with these long lines. This represents a cloud with rain coming down. Rain was becoming very scarce at that time, and they would have used this cave to pray for rain.
But with the monsoon now several thousand miles south, their prayers could not be answered.
Well, this cave must have been a very important sacred place for these people at a time when things were getting really bad.
Eventually, despite these rituals, the force of this change was so great, they had no choice but to leave.
Here in this cave we have the sand and we have the handprints, which is the last message left by the Saharan population.
The story of this cave started with a tilt in the Earth's axis that stopped the rain falling on the Sahara. What must have seemed like a never-ending drought would, in just 200 years, turn a gentle, fertile region the size of the United States into a brutal, searing wilderness, the wasteland we see today. This would be the biggest environmental upheaval of the last 10,000 years. Those that could must have migrated east to their closest source of water, the valley of the Nile, a beacon of green in the vast desert. This exodus had a surprising outcome. The death of one culture 5,500 years ago would lead to the birth of one of the most advanced civilizations on the planet.
It was the drying of the desert that led to this great civilization. People came from different places in the desert, established their villages, and within a very short time, they began to have the basic ingredients for the rise of Egyptian civilization. So climate change, in this particular case, stimulated one of the most spectacular events in world history.
The investigation into how quickly the Sahara returns to desert has uncovered two striking clues. Ostrich eggshell beads show people and animals inhabited a green Sahara just 7,000 years ago. Ocean sediments show that the Sahara returned to desert at breakneck pace in just 200 years. The next wobble in the Earth's axis is set for 15,000 years from now. Only then will the Sahara turn lush and green again. But now, modern technology is finding ways to speed up that process. The investigation into the Sahara Desert's eventful past now moves to the last 100 years. In 1956, French prospectors discovered vast reserves of oil in the Sahara. This triggered an oil rush that led to drilling across the desert. Then, they struck something unexpected under the sand: huge quantities of fresh water. It seemed the Sahara had another secret to reveal.
So this is a classic pumped well drilled for irrigating the fields, and the water is actually pretty hot, which means it's coming up from a considerable depth.
The deeper the well, the hotter the water. Water from wells in the Sahara can reach up to 150 degrees Fahrenheit. Such a high temperature means the pump is drawing water from far enough underground to be warmed by the Earth's internal heat.
So pumps like these can bring up water from 3/4 of a mile underground or even deeper.
With no rain for years at a time, this water must be coming from somewhere. Smith spots another clue.
Actually, when I look at the surroundings of the well, I can see some orangish-red iron staining.
This is hematite, a mineral that is typically found in water that's been underground for a long time. Combined with the temperature, this points to some kind of deep reservoir. Scientists say that, astonishingly, great quantities of water lie under much of the Sahara. The key is in the sandstone. Sandstone is made from layers of sand compacted into rock over millions of years.
So what's really incredible about sandstone like this is just how good it is at holding water. And that's because there's a lot of pore spaces between the sand grains that are actually really big. If I pour some water on this rock, just like would have happened when it rained over the Sahara, it soaks right in.
Scientists now know that every 20,000 years, a wobble in the Earth's orbit shifts the monsoon north, so rain pours down onto the desert.
Much of that rain that fell over the Sahara is now stored underground.
It's called the Nubian Sandstone Aquifer, and like a giant subterranean sponge, it sits below Egypt, Libya, and Sudan.
Though there's nothing but sand and rock on the surface, under the ground beneath my feet is as much water as there is in the Great Lakes.
The presence of a reservoir, even one deep underground, is surprising, given the Sahara's searingly hot temperatures. In 1922, in neighboring Libya, the mercury touched 136 degrees, a record still not beaten. But ironically, the water is protected by the desert itself. Layers of clay encase the sandstone. The clay keeps out the harsh sun. It also acts as a sealant, trapping the water within the rocks and creating pressure. Fault lines in this clay are the source of the desert's famous oases.
So this is a natural spring where water is coming up from the Nubian Aquifer under its own pressure. This is actually fossil water. It's been dated to be up to 1 million years old.
This reserve of water is a legacy of the Sahara's lush green past, the remains of its giant lakes and rivers. And this is just one aquifer. Scientists are now using ground-penetrating radar to locate and map other aquifers across the Sahara. They hold the promise of even more fresh water. This new technology offers hope that the desert may once more turn green, reclaimed for agriculture and farming. If all goes to plan, eventually there will be 200 wells here. But drilling could prove a short-term solution.
This is fossil groundwater. It's not being renewed. So eventually, you're going to run out. Water that supported prehistoric occupants in the area and accumulated over 1 million years is potentially going to be gone in less than 100.
Once the underground water dries up, the desert will have to wait another 15,000 years before once more the Earth's wobble turns it green again. The mystery of what created and changed the Sahara Desert has revealed a turbulent past. Whale bones in the desert show that 40 million years ago, the Sahara was a seabed. Deep ocean cores containing windblown sand reveal the date it dried up, 3 million years ago. Freshwater shells show that 90,000 years ago, a wobble in the Earth's axis created giant lakes and rivers and turned the Sahara green every 20,000 years. Ostrich eggshell beads indicate that just 7,000 years ago, the Sahara enjoyed its final burst of life before returning to desert. The secrets of the Sahara have finally been revealed. This desert is not a static wasteland. It's dynamic and full of life, capable of blossoming into lush green terrain. This vast, majestic land continues to shift, change, and evolve, much like the Earth itself.